else on this app. Window, desktop. Let me just share the channel screen, and then we'll have a quick look around and see. Or I'll have a quick look around and see where there is anything. Right. So here, somewhere here's Equatio. Oh, here it is. Right. Okay, now this here is speech input. So I wanted to show you how speech input works. And I got it to work yesterday evening. So hopefully that'll work again. So let's try something. X squared plus bx plus c. Right, so what can we observe? That unfortunately now the left-hand side has vanished as soon as I hit stop. But for some reason it had understood the bx. Although it had it capitalized, and the math that comes out misses the bx. Let's try that again. Let's just go. 8 times x squared plus bx plus c. Right. Sorry. Yes, so that is the problem. We can't really look at what is on the left-hand side. See, it takes everything I take now. But just to make sure that we see, so 8 times x, instead of a, it understood 8. The plus bx, it got the bx right, but then didn't translate it into the math on the other side. Plus c, all that would have worked. Obviously, now we're going a bit far. And you can see it tries to desperately find some math in what I'm saying at the moment. So that's not really good. Let's try one more attempt with something slightly more complex. Square root of the fraction from 1 to over x. Oops, maybe I should have cleaned the side. Let's clean that. Oh, all right. The square root of 1 over x. Oops, sorry. Switch on again. The square root of 1 over x. So it got the square root right, as you can see here on the left, but for some reason, then it didn't insert it. Okay, let's try one more. The square root of the fraction of a over b. Well, that is actually not too bad. I mean, the a over b, it didn't quite get the a over b, so it made an a divided, so beveled a fraction out of it rather than a proper fraction. But in terms of recognition, that was actually not too bad. Let's try one function to see where that can do those. Oops, let's clean that. Clean. Oops, undefined. We don't want undefined. All right. Sine of x squared plus cosine of x squared equals 1. Wow. I'm impressed. Now that one worked really well, but you know, you can see there's still some ways to go. It's not perfect yet, and we can now use that and insert that somewhere where we want to have it inserted. Well, obviously we can't really insert it in any of these pages here, but if we had now some document here, we could take this math. Oops. Oh, that's interesting. So it automatically opens my Word and inserts it into Word. Go away, license agreement. Now it's gone, of course. Let's try it again. What happens? No, right, so it inserted the math in here. And, oops, and of course now it's gone again. There it is. So it Just close, please. Whatever. Right, so the mouse is in there, and I'm not quite sure whether this is now as an image or whether this is something I can actually edit. If somebody can tell me how I can edit a math expression in Word, then I could try that. Is anybody familiar with that? Hello?
The product activation is failed, so it won't allow you to edit anything on your screen.
No? Where would it normally be?
I guess it will be in insert equation. You can go to insert.
Right.
And then
Volker,
there
you can just press Alt equals to.
yes, in symbol equation.
Alt what? Alt
Alt
equals?
plus, yeah, Alt plus equals.
I'm trying here. Alt plus equals doesn't do anything. Maybe it's because the product activation failed. I don't know. It's not, yeah. Yeah, this looks just from kind of cursoring over it. I don't know. You might probably not be able to see that very well, but I can cursor it over it in one go, which generally suggests this is a single element, meaning some sort of a graphics. Yeah, I don't know. Whatever it is, we don't know.
No, but you try to change the font. Let us see, does it change? Go to the home.
Can I change a font here? That's all grayed out.
No, I think there is some activation issue, so it is not actually.
Yeah.
Some other issues.
Yes, so it's
some licensing.
Mine are paying licensing fees to Microsoft. No, well, this is a standard university issue machine, so I could get the license, but I never bothered. And because I don't really use the Microsoft Office suite. Anyway, but just to show you, so this worked in some way. Let's have a look whether we can take the screenshot just for the fun of it. Yes, so at least that works. So we can kind of go back and forth, and then clearly we've taken it now again from the Word document and not from the actual math element that was inside the equation environment.
But there was no, in this particular software, was there any voice training? No voice training. It worked out of the box like what you did, because it's
what I did was now out of the box. Yes, there was no training or whatsoever involved. So there's the usual bias that could come in. So one thing, and in speech recognition, there's some serious biases. We know that, and there's a lot in the news about it lately. One is, for instance, that I'm a foreign speaker, meaning that my accent might not be perfectly suitable for that. I mean, I've seen Martin McKay. He used to be the CTO, now CEO of Textile. He demoed it to me once at a CSUN, and it worked fairly well for him. Now he's got a fairly thick Northern Irish accent, so maybe I could try it with an Irish accent, but I don't really want to draw that here. I don't know. It's so there might be various things which could possibly improve that. And as I said, I've only had that version installed yesterday to play with it. And what I wanted to show you one other thing, but I'll show you this on my regular machine now on here. And let me switch over to where my slides are and everything else. If I can manage to get rid of this here. So, somewhere should be Teams. There it is.
Yeah, you're muted now.
Is that better?
Yeah, yeah.
Oops. I have to switch this one off, otherwise you will hear a lot of echoes. Right, and one more thing I wanted to play with while we are at it is handwriting recognition. Since we have the system available, we might as well try it. And let me get that going. So, have I shared my screen already? No, I have not. Can you please confirm that you can see my screen?
Yes, we can see. We can see. Go ahead. Please.
Hello, anyone?
Yeah, we can see the screen. Yes.
Yes, Volker,
Sorry.
we can see your screen.
I'm sorry, I hadn't switched on my sound on this machine. It's very challenging. Right. Yes, right. So this is an experiment I did yesterday, and let me try to. Thank you, Equatio. All we want is have that on the page. Can you see my video?
No, not yet.
No. Right. So I'll show you first the tools I'm working with. So this is a Wacom in. Can you see my video now?
Yeah.
Yes.
For those of you who can't see it, I'll explain it in a bit more detail. So this is a Wacom tablet. So it's as an input device. It kind of works similar to a mouse, just that you have a big pen and you have a big tablet, which effectively corresponds to the size of your screen. And then it's obviously you can just write. It's much easier to do handwriting input on software like Equatio or any other handwriting input software. Let's have a look. So here's the handwriting recognition. And now the challenging bit is always to get to the right place on the tablet so you can actually do something. Let's just do something. Okay, so we just had the sine of x squared plus cosine of x squared equals 1, right? Wow, that works. That was nice. Let's just insert that and see how that works. And let's start afresh. Let's do something a bit more exciting. What are we getting? What's happened here? I don't want that. Right. So I've probably put my pen down in the wrong place. What are we going to do? We're going to do an integral from 1. Let's see. Integrals are always interesting. 1 to infinity x over n dx. Right, and now obviously I forgot that I actually want to sum over things here as well. Oops, that's not a sum here. Let's get a sum equals n equals 0 to minus infinity, say. Let's see what it's doing now. Well, where's my minus? So it didn't get the minus. Hello. There's the minus. And now let's make an equality out of this and just say, oh, well, that goes to a product from I equals 0 to j, where j is whatever, less than. Oh, that's wrong. Yes, so less than 0. It doesn't really make a lot of sense, but let's add a j squared here just for the fun of it to see whether it manages to get something in there. And all of a sudden you realize it stops doing the right recognition and all of a sudden does a different, recognizes what it recognized initially correctly as a 0 as a sigma. That's obviously not nice. We don't want that. But unfortunately, there's no way of just erasing bits here on that end. And just say, okay, I want to get rid of this. I can't really do that. I don't know. I'll try it anyway. Let's just cancel that out. Whoops! Now we've got a square root. That's all not great, right? So we would have to restart and do that. And let's work just for the fun of it, because you can see here, over here, there's an empty element. So that's not incomplete. Let's see what it does when I do an insert math. Can it do that? Yeah. Well, let's see when it tries to speak that to see what happens then. That's effectively a test for my system. What's going on?
The sum from n equals 0 to negative infinity of the integral from 1 to infinity of x over n dx sub I equals the square root of the fraction with numerator j and denominator I to the first power minus o raised to the j squared power times sigma is less than 0.
Well, I feel there was a bit of cheating going on, because it got rid of the 1 over nothing and made effectively a correct element out of there. So this here, it ignored that bit, which I find is cheating, because I would have been very curious what the system produces in terms of speech output for that. Right. Anything else you would like to see while we're at that, before I move on and actually go into the real lecture of today?
You see, after you put in that j square, it actually distorted a lot of things. So the positional information is also it is taking.
Yes.
J square was coming just above that I equal to 0. So.
Yes, I think so too, because it's online handwriting recognition, so it takes into account what element comes first and second and so on, right? And therefore these systems generally are not biased towards inserting something a posteriori. So if you have something, let's try that again. That's an interesting experiment. So let's try to go for S for the sine. Whatever, sine. Let's see where that, got the sign right. So let's put an x here plus y. Well, but actually I wanted to have an ix plus. Let's see where, yeah, well, that worked. And let's put a square here. And let's put another square there. That seemed to work. And let's put some underscore here. Let's see whether this does anything. Let's put a j there. Well. Let's put a sum over the whole thing. Well, so that kind of contradicts my hypothesis that it's not good at recognizing when you do corrections somewhere over there. I mean, obviously, if I now start screwing up the sign, I'm pretty sure something will happen here. Let's try something there. No. What about that? Well,
the last time what happened, Volker, was that after you put that j square, it actually removed that product sign.
Yeah. So it
actually changed that product sign to a square root, complete square root, after you put the j square. Otherwise, initially it was.
So now that's a pi, right? I equals 0 to infinity. Let's see. Yeah, now it recognizes the product, and now let's put something. Let's put a j underneath here, j greater I. That's a bit nasty. Yeah, now it flipped entirely.
That's what happened last time also.
Yes. So the product sign is clearly a bit unstable. Now you have an 11 instead of the 2. But yeah, but okay. Well, so much for these experiments. Let me change my technical setup again, so we can. All right. So that was playing around with these various tools and tool sets, and so I've inquired, because yesterday was also the question whether math snippets or math picks, math snips or whatever it's called. Where is it? It's I don't have it running anymore. Is whether Equatio is using that. I've asked the question. I haven't had a reply yet, but I'll let you know as soon as if they divulge the information. Right. Today, what are we going to do today? apart from playing around with various input formats. We're still in a way in the wrap up of math, but I think I'll probably go fast on that one, because there's the only point we didn't really get to yesterday was about born accessible documents, and I've got a few slides on PDF documents, but that's not really, we don't really have to go into those details very much. And then I actually finally want to dive into diagrams and how to make those accessible and what things we can do to play with those. Right, so just to wrap up about documents in general and math documents in particular, there's a number of things we haven't talked about yet. One is, for instance, PDF documents as such, as a source of accessible documents. We haven't really talked about EPUBs and similar formats like DAISY, and obviously what we really have talked about is web documents. So just for PDF documents, I've been slacking off PDF throughout the lecture so far a bit, saying that it's not, it's a print-only format in many ways, and that is not entirely true. There's various versions which allow you to make PDF accessible. Particularly, there's the PDF UA, which is Universal Accessible Standard, I believe. There's a couple of problems with these. First of all, it still relies very much on the goodwill of the authors, whether that will become a good accessible source or not. And secondly, when generating PDFs, most generators, i.e. the export functions from Word, and as well as generators like LaTeX and others, are not necessarily great at generating accessible PDFs. So Word is fairly good when it comes to things like reading order, putting in headers, footers, everything in the right nesting depth. You can actually also give alt text there, which sometimes get lost, unfortunately, but most of the times actually are being translated correctly into alt text for diagrams or for graphics in PDF. You can't really do anything about math, of course, even from Word, and there's not much else you can do in anything that's a bit more advanced. For PDF, tables, for instance, is difficult to make accessible via the original Word source, and the PDF will have a lot of problems. Now, there's various ways how to do these things, then fix them up manually. Particularly, there's Acrobat Pro, which is really the only software which can fix up a PDF very well. And unfortunately, it's proprietary. It only runs on a number of platforms. I think Mac, and I used to have it on a Mac, but it also runs on Windows. Obviously, it doesn't run on other platforms, and moreover, it's not free. So in many ways, if you want to put in the effort to make something accessible, and therefore be kind of good to the community, you have to pay quite dearly in order to get the software which allows you to do that, which is obviously a severe drawback, in my opinion at least, when it comes to making PDF documents accessible. And it's also a severe drawback in the sense that once the PDF document is set, it's fairly much set in stone. So for those of you who have submitted, say, conference papers or anything to conferences where they require accessible PDFs, what normally happens is that you spend an hour or two making this document accessible with Acrobat Pro, and then you find the typo or two, which you have to correct, and then you have to start all over again, right? Because you have to go back into your Word and your LaTeX, and you have to correct the error, you have to generate the PDF, and the PDF is yet again inaccessible as it was before. So from that point of view, this is it is still not a good solution, and therefore generating accessible PDFs is something that is very difficult to do. There's alternative workflows I can recommend in particular for LaTeX. If you have a LaTeX document, instead of putting that straight away into PDF, it's normally helpful to translate it into Word first with Pandoc and then make it into a PDF. At least you get the reading order most of the time correct, and the nesting structure of your headers, etc., which you do not really get out of LaTeX directly. So general credo there is always LaTeX is great for math, but not really that great for structure. Right, I've already mentioned that, so we're not going to discuss any more there. Then the final format that we haven't really discussed is something like EPUB. General, what can always say is, well, EPUB is very close to HTML5, so in many ways your sources will still work. There's a couple of issues which have primarily to do with things like that EPUB uses XHTML underlying instead of pure HTML, meaning that it has to handle namespaces, etc., which HTML doesn't. So you can run into various problems when it comes to these things, in particular when you have accessible structures in there, as we've seen previously, like the math checks math, some of it, which is accessible via alternative attributes, which do not necessarily translate that well into XHTML. Same things for diagrams, which we will see later. And also, if you have an EPUB reader, it has to have things like JavaScript, etc., in order to get any of the more advanced accessibility features out. So I think, let me have a look. There's a test with an EPUB reader for, I think, a document. Let me have a quick look where the document is. That's the EPUB document. So this is an EPUB document of the reports for the diagram center, which is centered by Benedict. It's all very nice and very lovely. So this is an EPUB. One of the problems is that many of these things that you have in there, which should be accessible, because obviously the idea of the diagram center was to make things accessible for people, have to be left out because simply they're not accessible. So in the EPUB reader, and obviously, as usual, I refuse to take my things out. So where are my STEM documents? Let's have a quick look. References, multimodal STEM documents. That's my stuff here, of course, where everything is in there. And there's diagrams and there's math, and it's not being. And you can see the math here. If you can, oops, let me make them slightly larger. So this is a piece of mathematics that's actually being rendered. Right. Oh, it has been rendered after a fashion. It takes a while to be rendered, but there's some other things in there that haven't been rendered, and I'll show those to you how they actually should look like, and how they look like in exactly one EPUB reader, for which all this has been optimized. Unfortunately, so the way it should look like is that you should have a nicely rendered diagram here, and then you should be able to actually go there and change colors and navigate this and zoom and do all kinds of nice little things with SVG. Unfortunately, that doesn't always work with EPUBs. I've been told it works with one reader. Unfortunately, that's only available for iOS and Android, and therefore I can't really show it to you online here now, unless we change to yet another system, which I'm not prepared to do. Right, final thing I wanted to mention, alternative formats. We've already talked briefly about alternative formats, that things like Braille. Here's a math equation again, which with output in Braille. So the Braille you see on the screen would normally be pushed straight to a Braille display if you have one attached to your to your computer. Now, obviously, it's not just Braille displays you want to build alternative formats for, but other things you want to translate are, for instance, directly documents straight into Braille output. And that is not necessarily a straightforward and easy thing to do. As a matter of fact, it's generally a very long-winded process. So it takes, for instance, an estimate for a textbook to be translated for a single student in an American university is about 6 months. By some specialist transcribers, and most of it is being done by hand. Obviously, some of the general text is transcribed directly, but if there's a lot of math in it, etc., all of these things are being done explicitly by hand, which you can imagine is very, very time consuming, takes a long time. So we're currently working on some alternative for that. We're working on automated support in order to get that going. So there's particular, I've showed you before, the pretext format from which Braille, embossable Braille is being derived. And the idea there is that the pretext format is effectively an XML markup that has LaTeX formulas in it. And then Rob Beezer is the guy who does most of the translation. He uses LibLouis for the text, which is quite precise when it comes to text, but not necessarily good when it comes to structure of the text, i.e. things like sections, etc. And then uses MathJax for the rendering with the SREs and Nemeth translation in order to get the Nemeth out in order. And tactile graphics are also being translated. I'll have a bit on tactile graphics in the second part of this lecture. I'll show you a few there. And what's currently being done is this abstract algebra book. So here are the abstract algebra. Here are all the formulas. And then these formulas are being translated automatically, and they're all being extracted. And when they're extracted, they can then be viewed, as well as further, if some of the automatic transcription fails, they can be corrected in an automated tool that we've put together. And here's the automated tool. I'll show that to you very quickly. Oops, let me log in. It's open source, freely available. You still have to log in. Because it uses Google's Firebase underneath, and this is the entire abstract algebra book, taken apart, if you like, not down here. This here is the abstract algebra book. Sorry, that's the abstract algebra book. All formulas in the abstract algebra book that are triaged to a particular type. And then we condense them down to the kind of the exciting ones, if you like. Also, partially automatically, they're being condensed down. And those are then the ones that actually the transcribers first go through. And I'll show you some of these. And so you can see that the actual equation there, you can then start changing the equation. And you can see here the Braille that comes out. And let me make that a bit larger, and then you can kind of use various inputs. So now we've got a 5 in there, and say number 5 in the end. It doesn't. We don't have a translation process for the renderer yet, unfortunately. But you can see how the actual Braille changes, and you have references that allow you then, or the transcribers rather, to go straight in the book and see where, in which context, some of these elements actually occur. And in that book, then, obviously here again, there's the MathJax, and you can look at it, and you can look at the mathmal code and the tech commands and all these things. And this way, the transcribers get a good idea of what they are actually transcribing, or what the formulas they're looking at. Because you should always think about these transcribers, they're generally not mathematicians. They know their Nemeth very well, but they don't really know the mathematical context. And therefore, it can be helpful for them to actually look at where the math comes from and what the meaning of the math actually is, if it's not clear from just looking at the formula on its own. Right, so this is, I think, all I wanted to show you for that. Oops, there are some of the graphics. I'll show those to you after the break. Let's have a break now. And let's take 3 to 4 minutes, maybe not too much, because I've wasted so much time at the beginning not being able to get into the Teams.
Okay, in 3 minutes we will assemble. Yes.